Okay, another problem here. Example 4, find the derivative of the sine of tangent 7x. So we have a composition here of a composition of a composition. So sine of, in other words, sine composed with a tangent, tangent composed with 7x. So when we differentiate, we're going to have three derivatives. First one is derivative of the sine. Second one will be derivative of a tangent. And the third one will be derivative of 7x. So let's start off here. We can use our proper notation. It looks like this. And first we'll start with that sine. So we'll have a cosine. And leave the other part there. Then we'll have times, what's the derivative of a tangent? You remember, it's a secant squared. Leave that 7x there. Now take care of the 7x. Derivative of 7x is a 7. There's not a lot you can do with this, except maybe bring that 7 up in front. So you have this, and then you have the secant squared of 7x. I guess I really don't need all those parentheses. So you could write it like this, cosine of, leave the 7x in parentheses, but then you could write secant squared of 7x like that. Okay, it's not really that important. The parentheses, you're safe with the parentheses. If you just leave them in, it's okay. All right, and that was a short one, so let's get this other one in here. Right below it, number 5. Okay, you've got a composition here, square root of a square root plus a 1. So there's a sum in here. And this part of the function is itself a composition. So we'll handle one part at a time. So we got an overall square root function. So when we differentiate, we will have 1/2, and you'll bring that back down. I'm going to leave this part in here, t plus 1 plus a 1, and you'll write that as a negative half. Okay, now we need the derivative of this inside part here. Okay, so let me erase that. I don't want you to think this is a fraction. It's not. We need the derivative of that inside part in here now, this part. That's got to go out here. So let's go ahead and do that. Derivative of that inside part, you will have a 1/2 t plus 1 to the negative half times a 1. Derivative of t plus 1 is 1. So you don't really notice the 1 there, but had that been 2t plus 1, then this would have been a 2, because the derivative of 2t plus 1 would have been a 2. But it is just a t plus 1, so its derivative is just the 1 in front of the t. Okay, that takes care of that part. Now plus the 1, well, that's plus a 0, so it doesn't show up at all. Okay. So now finally what we can write this as, we've got a 1/2 and a 1/2 here. They could be written as a 1/4. This part, let me see, let's fix that. I want to make it look nice if we can. So we'll have 1 over, you'll have 4, and you will have the square root of the square root of t plus 1 plus a 1. And then you'll have this part, which is another square root of a t plus 1. Now, if you're feeling adventurous, and you could continue a little bit further with this and write it under 1 radical, but you'd probably be safe just leaving it like this. It looks a little weird, but you could get these as 1 radical. You just got to be careful inside there when you do that, because if you bring that under, bring this under, you'll have this root t plus 1 plus a 1, and that quantity will be multiplied by this t plus 1 like that. Okay, so it's not as nice as you might have thought it might have become. I'd stop there. This is one of those problems you quit while you're ahead. Okay.